Well, good morning and good afternoon for some. My name is Jennifer Joyce, and I am the Regional Vice President for Sales for the Western Territory here at Conducive Technologies, talking with you today about how we can achieve a 2x faster SQL experience guaranteed. Just want to start with a couple housekeeping things, really kind of the agenda today. This webinar is really broken out into two parts. The first part is going to be what we would consider the thought leadership portion of the webinar, and this is where we just really kind of dig in under the hood a little, get into the technology stack to explain what are some of the I/O inefficiencies that are occurring, just some of the I/O degradation issues that are happening in the environment, especially if you're running SQL, and particularly if you virtualized, but we know that a lot of physical servers are still plagued by some of the things we're going to talk about today as well. So really we just want to take a look at what's happening under the hood that's stealing the underlying IOPS and the throughput that might be causing your underlying storage subsystem to work a lot harder than it has to, and ultimately why you're getting less performance than you really should be on the SQL workloads and the infrastructure that you've already invested in. The second part of the webinar, we're really going to focus on some inherent I/O penalties that are occurring, kind of a couple of them that we're going to really bring to light here. And we'll give you an overview of, just no more than 10 minutes of what our software does. It is just a real quick intro to it here. Our product is a set and forget software utility, 100% software, no hardware components at all. It runs in the background. It is dedicated for Windows environments. And it is really tackling those I/O inefficiencies that we're talking about solving, that we can guarantee that our customers can get that 2x faster SQL experience. So, obviously the compelling event here is how you can get more performance out of the environment you already have without having to spend more money on expensive hardware and just throwing more hardware at the problem. So this is really a unique 100% software approach that you'll be hearing about today. And one other housekeeping item here, we're going to be giving a complimentary NFR, not for resale copy of our software, valued at more than $500 MSRP as a thank you for attending the webinar today, because really, ultimately, the proof is in the pudding. We want you to use the software. We want you to try it. And on the line with me is my partner in crime, Howard Butler. Howard is the Senior Director of Systems Engineering. And Howard, I wanted to introduce him real quick. For any of you guys out there that are car aficionados, Howard is also a race car instructor. So not only does he specialize in getting computers to accelerate as much as possible, he also does the same thing with cars. So Howard, over to you.
All right, Jennifer. Well, thank you very much. Always glad to join you here, and don't let her title fool you guys. Although she's the Regional VP of Sales, she too is quite technical. So between the two of us, I'm sure we'll be able to answer and address all of your questions as we roll through this webinar.
Well, thank you, Howard. And one other housekeeping item before we really dive in here is that we do have a Q&A box here. And, we really, usually at the bottom of the hour, we have a very robust Q&A session. So do not be shy. Do not hold back. Chances are if you were thinking the question, someone else has got the question too, and we can really get a lot of great dialogue going on here. So we'll get through the content of the webinar in the first 30 minutes here. That's the plan. And then anything that anyone who wants to hang on will stay on as long as there's questions being dropped into the box. So let's go ahead and dive in now that we've got some of the Q&A, the housekeeping items touched on here. So first off, I personally, when I go in and I look at products and I'm considering something, I really want to know who I'm talking to. So I'm not going to beat the obligatory corporate marketing slide to death here. We won't spend much time on this, but I think it's important to give you some context of who we are, where we come from, and why we feel we have any credibility to talk about what we're talking about today. So right to the point on this, we're actually a 35-year-old software company. And from the best that we can tell, we are the 12th oldest software company in the world. We originally started out as a company known as Diskkeeper. There's probably a lot of you on the phone that's got some brand name recognition with Diskkeeper and have heard of it and possibly even used our hardware to optimize hard disk drives in the past. But about 5-6 years ago, we brought some very revolutionary intellectual property into the marketplace, and it had absolutely nothing to do with our defragmentation days. And it was really all about how can we reduce the noisy I/O. All of the noisy, unnecessary I/O, as it turns out, especially on any given SQL Server system, there's about 30 to 40% of the I/O traffic that is just pure noise. It's just stealing IOPS, and it's stealing throughput. And in fact, those customers of ours who on those really heavy workloads add just a little more memory on the server side can really take the most full advantage of our software. Now, most of the time there's already enough memory there. You don't have to add a whole lot, but we can take it case by case. Now, for this innovative work that we did, you'll notice here that Gartner tapped us as Cool Vendor of the Year when we launched this into the marketplace. And one of the reasons they tapped us Cool Vendor instead of throwing us into a quadrant is because nobody else does what we do. There's literally no one else they could compare us to. This is a completely unique solution. And over the last 5 years, we've had a lot of really good market growth with this product. It's now used by over 2,500 mid-market to large enterprise customers. And we have the iterations and pieces of our technology OEM'd by 9 of the top 10 big PC manufacturers. You can see the list there, the Samsungs, Dells, and SanDisks of the world. So if you haven't heard of us, you've certainly heard of them, and our solutions baked into their product as well. And part of that technology is what we'll be talking about today with Velocity. So really just wanted to kind of give you some context and background of who we are and what we do. So we'll move on here. I wanted to just first talk about a survey that we recently did. And this kind of moves us into that thought leadership portion of the conversation that I was mentioning. So the first thing that I wanted to really kind of talk about here is what's happening in the marketplace, really. We did this survey, and one of the things that came out of the survey was we asked IT professionals, of all the workloads that you're having trouble with, which ones are you having the most trouble with, and are you having actual performance degradation to the point of having user complaints and having issues? And we actually had 28% of respondents raise their hands and say, yep, well, that's us. We're having that issue. So if you're on the call today, chances are you fit into that kind of 28% bracket. And we've repeated this survey for a number of years in a row. And last year it was at 27%. So we're not seeing any significant improvement in these results, and we expect that to continue going forward. Another thing that we did was we looked at, we said, hey, of all of your IO-intensive applications that you're supporting, which ones are you challenged by the most? And obviously SQL kept rising to the top of that conversation, very much so. Now, before I continue on to talk a little bit about what this looks like as far as the technology goes, Howard, I just wanted to mention real quick as well that, we had recently gotten a certification from Microsoft, didn't we? And this was a pretty elite certification.
Yeah, you're right, Jennifer. And I kind of really do consider that a pretty outstanding certification. Microsoft has several different levels to make sure that other applications, like ourselves, are fully compatible with their software platforms and so forth, and in this case, SQL Server. And as you said, we're the only software vendor in there, and we've made, and we're a pretty good company with other people like EMC, Dell, HP, and besides all the rigorous testing that was done, we also had to go through a panelist of SQL experts to get past this certification. So it really is a pretty big feather in our cap and a really nice certification, Jennifer.
Thanks a lot, Howard. And so with all of that, with kind of where we've been in the industry, the 35 years of legacy, the software platforms we've had in the past and what we have today, the certifications we have, and then mixing all that in with what we're looking at here of so many people having issues with performance. And guys, you guys are probably a lot of you on this call. We've got well over 100 people on the call today, have probably experienced this no matter what your hardware is. You're either on direct attached physical workloads, you've got hybrid workloads, you've got all flash, some of you have HCI, and you're on the call today for a reason, because you're looking for some solutions of how do we maximize the workloads that we have. Now, let's take a quick look at what we want the environment to look like. I think it's a good thing to start with kind of what an ideal environment would look like before the I/O degradation that I'm talking about gets to creep in. So as you can see here on this screen, there's really, I mean, this is obviously oversimplified. It's a really rudimentary extraction of the I/O profile, but I think what the takeaway off here is pretty obvious. And what you can see is that we want to have you get nice, large, clean, contiguous writes and reads. You can see here that this profile would be getting a very healthy payload of data where every I/O operation is carrying as much as it can. It's sequential in nature. This is a lot easier to process than small split randomized I/O profiles. And this is really what we would want your environment to look like so you can get the most performance out of it. But what's actually happening, and we'll just kind of do a comparison here, and what you see here is that suddenly now this environment, there's I/O characteristics that are much smaller and more fractured and more random than they need to be. And we'll refer to this by kind of that death by 1,000 cuts scenario, where your underlying architecture is really processing workloads and ultimately having to really work much harder than it needs to be. It's kind of like pouring molasses all over your flash storage or your hybrid storage. And, you're really getting penalized, and you're penalizing all of that hardware and what you have there with what we would call the perfect trifecta for bad storage performance: small, fractured, random I/O. And one thing, I'll come back to this in a little bit. One thing I'll point out, though, that with all of the hardware we have out there these days, the disk used to be the weak link. It's not anymore. You've got a lot of IOPS and I/O processing out there. What the weak link is now is upstream. It's with the OS. And the OS is pouring so much inefficiency and excess I/O in the small split randomized I/O profile that it's still swamping environments. Now, we're just going to dig in under the hood just a little bit here to see what's actually going on and causing this. There's really two different I/O penalties that are occurring that are penalizing performance in your space. The first one I'm going to focus is down here on the bottom of the slide, the I/O blender effect. Now, I cannot emphasize enough how important this is and how penalizing this is. And I could not have had it more clearly illustrated to me than on a POC that Howard and I just wrapped up just a couple of weeks ago. We just did the review call at the end of October. And it's interesting because, we ended up having a POC done on an all-flash pure SAN with 600,000 IOPS. Crazy, crazy horsepower, 12 physical servers with a variety of workloads, and we were able to, we installed on just one server, the server they really wanted to improve, their data warehouse server, and they saw no effect. And at the beginning of the POC, I let them know, what I'm really going to recommend is I think we might have the I/O blender effect going on here. I'm going to recommend you install on all 12 physical servers attached to that SAN. I mean, take the hypervisor out of the mix here. We didn't even have that layer of complexity, right? And so they didn't get the results by just deploying to the one server, and they got their change control. A month later, they got deployed to all 12 servers, and boom, we took 4 hours off of that data warehouse workload time. It started at 9 p.m., used to finish at 5 a.m. or 4 a.m., and now it's finishing at midnight. So that I/O blender effect cannot be stressed enough of how much of an impact the neighboring workloads could be dragging down and affecting the key workloads you care the most about. So that is really, really a huge part of this. And you put just, and they can't even virtualize that workload, but now you enter in virtualization. And as great as virtualization is for efficiency and cost savings on the hardware footprint, you start adding another VM and a third VM and a fourth VM and a fifth VM, and now you start seeing some of that performance get sucked out, and you're starting to talk about adding more shelves processing power, and you're kind of scratching your head on why you have ghost latency here and there you can't quite diagnose. This is the I/O blender effect at its worst. And then you move upstream a little bit, and you get the Windows I/O tax. Now, the Windows I/O tax is a completely different thing that really even compounds and exacerbates all of this further. Now, Windows natively breaks up files. It creates a lot of excess small files, a lot more than it needs to. And what we're going to do is talk today about how Windows creates that and what we're going to do to solve it. Now, one of the things that we've encountered a lot in these environments is that people don't tend to recognize the full performance penalty that is coming from both, one, the Windows Windows I/O tax, and then that force multiplier effect of the performance drag with the I/O blender effect. They're not seeing it because most people virtualize slowly over time, and most people are already fully virtualized by now, but that kind of slow growth of the VM environment didn't really let people see that performance drag start creeping in, and they kind of got used to it, sort of like getting in your car playing the radio. By the time you get out of the car, it's at top volume. You don't notice it. Next time you get into your car, it blasts you out. The same thing happens with gradual performance degradation. You don't notice it while it's creeping up on you, but once you get rid of it, you sure do notice how much better it is. And Howard, a good example of this is when we were working with Christus Health, which we've got a published case study with them. They're now deployed to 2,500 VMs throughout their data center with our software. But they had this happen to them, didn't they, Howard? They, I think you were involved in it. They actually virtualized overnight. So for them, they didn't have the slow creep. They went from a physical environment to overnight to a virtual environment, and that performance degradation was very, very obvious to them, Howard. And maybe I could ask you to share some of your insights into that event.
You know, they did their testing on individual systems. And, you know, kind of as they expected, that when they went from physical to virtual platforms, they assumed that they would get their same performance. But when they virtualized all those systems, unfortunately that didn't happen. They saw a pretty significant performance degradation. And during their analysis, what they found was that it wasn't a CPU problem. It wasn't a lack of memory. It was really an I/O bottleneck, Jennifer. And that's what caused their issues. And kind of their first reaction was, we're now going to have to upgrade all of their storage. So that way, you know, they could make use of, you know, an all-flash type storage array to kind of solve the issue. But before they did that, they got a copy of our software, and we were able to solve that I/O bottleneck, Jennifer. So rather than them spending $2 million for all new flash-type storage arrays, they were able to save that money, invest a small portion into our technology, and take that money to spend on other projects.
Yeah, and thank you, Howard. And as I mentioned, you can see that case study on our website. And like I said, they're on over 2,500 VMs now. And one thing I'm going to mention, Howard, is we were just in touch with them last month. They've now upgraded to Velocity 7, and they did it in about 3 weeks because there's no reboot required for our software. So as you guys are considering looking at our software for your environment, just be mindful that a POC or a proof of concept is very easy to do because this is a no reboot software. You can just literally deploy it and you're done. Now, one thing that I'm going to kind of touch on here is that, you know, as we've already talked about the 2 penalties in the environment, so I want to dive in a little bit more about this Windows I/O tax penalty and just talk about what's happening there, and just kind of some of the severe inefficiencies in the handoff of data between Windows and the OS and the underlying storage. There's really, you know, if you think about it, there's no APIs that are connecting the two other than using just the rudimentary frameworks that Windows has always used by addressing the logical disk to write data. And Howard, this creates a pretty serious problem because the Windows operating system, for any given file that should be written in red with just 1 or 2 IOs, or 3, just minimal operations, it really inflates it and actually creates about 30%, from our studies, about 30% more IO than really needs to be there. And ultimately, you know, this just ends up happening over and over again. So Howard, maybe you could just dive in a little bit for us here on what's actually happening here and why Windows is so inefficient in the handoff of data.
Well, you know, the Windows file system really does take more or less a one-size-fits-all approach, Jennifer. When a file gets created, modified, extended, whatnot, the file system doesn't really know how big that file ultimately is going to be. So what it will do is, rather than looking for the best possible fit, and this is on the logical side of the Windows system, it's going to look for the next fixed allocation size. And if that file write or extension is bigger than that next free space available, it'll fill what it can into that space and then go and find the next available free space and kind of go through that process over and over again until it has written all the data. Every one of those actions requires a separate individual I/O request to be sent from the guest VM to the hypervisor to the physical host and out across the storage. So with each of these extra IOs, you're getting these really small random IO requests, which are rather difficult and troublesome for the storage system to process. Instead, what you would really like to see are these much larger, nice sequential IOs. And we'll talk a little bit later on how we address this and make all that happen. But as you can see, now you're getting all of these small random IOs coming from the system itself. And if you ever look at the benchmarks of storage, you'll find that random IO requests are much more time-consuming and requires a lot more effort at the storage system than sequential IO does. So that's one of the reasons why sequential IO always outperforms random IO. So if we can enforce the fact and keep the system or help the system to do those nice sequential IOs, you're going to get far better performance out of your storage.
Thank you, Howard. And just a quick reminder, too, probably some people are starting to have some questions. I see one in the box already. So start dropping your questions in there. We'll get to them here at the bottom of the hour during the Q&A. One example anecdotally, and then I'll get on to the next slide here, but one example anecdotally was with the University of Illinois. They had their hardest hitting databases where their applications were actually using some Oracle as well as SQL. And they already had those databases running on Dell servers, so the latest compellent flash. And beginning when they first fired them up, they were great. But a year on, the performance really had degraded. So they, in researching what to do, they thought they're going to have to buy all more flash arrays to throw in there to get the IOPS to meet, keep up with their SLAs. And they found our software during the research, threw us in there, solved the problem. They were able to just keep the hardware in place that they had. So really just kind of goes to show with a couple of the experiences that we've had that just that newest, biggest iron sitting there isn't necessarily going to cut it. And, one of the things, we'll go ahead and advance the slide here. Oops, I think I made it bigger instead of advancing it. Okay, here we go. So we're going to go ahead and start talking a little bit about what we do to solve these issues. And, I mentioned that Howard and I would give you just a real quick overview of how we do this, and then we'll talk about getting that free copy of the NFR of the software handed off over to you. A couple of things to talk about, though, is that the first engines we're going to talk about really create that large contiguous write experience and get rid of all that fractured small split I/O. And we'll talk about the engine that does that. Then we're also going to talk about an engine that does some really advanced read caching and just how we really get a much more friendly I/O profile in your environment. And one thing I'll mention here that's real important is that this 100% software solution, as I mentioned earlier, it's just a very thin filter driver, really nominal overhead. We like to refer to it as a near zero overhead impact. And we would even challenge you to try to find the CPU footprint that it's consuming. It's really, really lightweight. So just be mindful that all the engines we're talking about really require next to no resources to be effective. And as we want to talk first about the first patented write optimization engine, and then second we'll talk about the read optimization engine. So Howard, first I'm going to start here on what we're doing to optimize writes. Now, we already talked about how Windows has this issue where and what it's doing and why it has the issue is that it's only looking for the next available allocation of the logical disk layer. Now, I'm not talking about storage at all. Keep in mind, Windows is file system based. Your storage is probably block based. We're talking about writing at the logical disk layer within NTFS. And Windows doesn't know the size of the file. It has no idea what the size is. Now, I'm going to give Windows a little credit here in the sense that on a freshly formatted NTFS volume, day one, kind of like University of Illinois that I mentioned, probably going to get ideal I/O performance on day one. But over time, it's going to start degrading, and it's not going to have the right size fit any longer, and you're going to lose that sequential traffic experience. So, Howard, one of the things that happens as this time goes on, one example here is that if we have, let's say it's a 64K file that's going to be trying to be written and the next available space, free space is degraded, it's only 4K in size, it'll fill that 4K. It's going to use it. It's going to use that next fit allocation, and then it'll split, find the next allocation, split, find the next, rinse and repeat until the entire thing has been fully written, Howard. And the patented engine we have can actually solve that problem and make sure that we're delivering that file optimally every single time with the optimum density per I/O. So maybe if you wouldn't mind, just take a quick moment here and explain what kind of intelligence we're adding here that enforces that type of optimization into the Windows OS.
Excellent. So as I said before, Jennifer, the file system doesn't really know how big that file that you're trying to create ultimately will wind up being. And, with that, Windows is just looking for the next available free space or next allocation. So what we're doing is something relatively simple. In the background, we're monitoring the behavior of the file system and the applications. And we're saying to ourselves, hey, this particular file type or this application is creating a particular file, it's getting extended and so forth. So we know precisely the exact characteristics of the way in which your applications are using the file system. And we can just feed that information back to Windows, back to the NTFS file system, so that way Windows and NTFS can make better choices when allocating space for the file. So instead of grabbing the next available free space, we can tell Windows, hey, by the way, there's this ideal location of where you can write the data and not have to incur all those tiny little fractured writes or continue to incur the penalty of split IOs. So you get a really nice sequential write right from the very beginning. So now, like I said, it's fairly simple in terms of providing that intelligence to the file system so it can do a better job. But I like to use this analogy for those that aren't quite file system experts. If you wanted to carry, let's say, a gallon of water across the room, you could envision doing that in, let's say, 100 small little tiny Dixie cups and go back and forth and back and forth and back and forth. Or wouldn't it be much more efficient if you just carried that jug of water in one single container and just moved it to the other side of the room all at once? So that's essentially kind of the analogy or the way, if you can think of things, to help enforce or make the file system behave more efficiently. So these nice sequential writes is a much better way to effectively write the data. And however you wrote the data, subsequently it's how it's going to be read back. So you kind of get a benefit on both sides of the equation there, Jennifer.
Thank you, Howard. And, one way that I kind of like to think of this engine, is that as it's feeding the intelligence into Windows to help it find the best allocation of the logical layers, is that this kind of gets us back to zero. I mean, this performance degradation is really dragging us down, and it's kind of taking us into negative performance territory. And this gets all of that 30 to 40% drag recovered and gets us back to where we should have been in the first place. The next engine is now going to catapult and accelerate us even further into positive territory, getting us, not only have we healed the damage that Windows is creating with all of that small split tiny I/O and then the compounding I/O blender effect, but now let's accelerate and get another 30 to 40% boost on top of recovering from the damage. And what that engine looks like is called IntelaMemory. Now this is our patented read caching engine. And I'm going to just pause here real quick to make a very, very, very big distinction between the engine we just talked about and the engine we're starting to talk about. Our IntelaWrite engine, all of that write, has nothing to do with any memory. Nothing's buffered. We're not using any DRAM for that. That is all passed through. With IntelaMemory, read-only caching. So I'm going to emphasize that because that question comes up all the time. We are not buffering or caching any writes. So on the IntelaMemory, we'll move on here. This is actually a DRAM read caching engine, and what we're establishing, think of it this way, think of this as a tier 0 cache strategy in your environment. Simply by leveraging the idle available DRAM that's sitting there already on any given VM or a physical server, and we're just utilizing that otherwise wasted resource, that memory that's just sitting there idle and free and going unused, and we're just putting it to good use. And we're going to serve a portion of your hot repetitive read traffic from it. And the real genius of this engine is that it's completely automatic. You don't have to carve out or allocate any memory for cache. And the software is aware moment by moment of how much memory is used and unused at any given moment, and it's only going to borrow a portion of that unused memory to serve hot reads. So that way you're never having to worry about any resource contention. You're never going to have to worry about memory starvation because the intelligence of this engine is so powerful and so completely dynamic. It just borrows what's free and available, and when it's needed, it releases immediately. Now, obviously, if you're in peak workloads and that memory starts getting gobbled up by other things, we back out. We're the guest, and we'll back out of that. So now I know that a lot of people hear this and think, okay, well, from previous experience, like, hey, SQL takes everything, right? When it comes to caching, people think, hey, we need to be capacity intensive to really take advantage of this and have a strong experience with this caching. And Howard, in our experience, we've looked at tens of thousands of servers, and that simply isn't true. We have found that if a customer just maintains, on average, 4 gigs of free memory available on most of their servers, that's going to be more than sufficient for us to jump in there and serve 30 to 50% of the read traffic directly from memory and offload it from storage. So it's not always being about capacity intensive. With our behavioral analytics engines in there, it's so powerful they can leverage just the little bit of DRAM that you have. And keep in mind that, as Howard has mentioned, it's 10 to 15 times faster than going down to SSD to your Tier 1 caching strategy there. So just a little bit goes a long way, and usually it's already sitting there idle, and we can put it to good use. So, Howard, maybe I'll just ask you for some extra, color or flavor around the IntelaMemory engine here.
So, you're right, Jennifer. There are several things that makes our technology rather unique with our IntelaMemory caching. And it's one of the reasons why 9 of the top 10 PC manufacturers license our technology. Of course, you haven't heard of us with them. That's because they license our technology under their own name. But the 2 things, as you indicate, is dynamic memory usage. We will only use memory that's free, available, idle, unused. And if the system or user running an application or something needs memory, we will detect that memory usage demand and give that memory back out of our cache, back to Windows, long before there's any type of memory constraint or memory contention. And the second part is what to put into our cache. There are various different type of caching algorithms or strategies. Some might say, oh, well, here's a read. Let's put it into cache and cross our fingers and hope that you read it again. That's simply not good enough. We're actually taking a more intelligent approach, and there has to be a compelling reason why we would even bother putting a read entry into the cache, and that is because we have strong belief, we've seen evidence in your environment where that particular range of logical blocks are being read quite frequently, and removing them from having to go out to storage would certainly go a long ways towards improving performance. So if we put it in the cache and be able to monitor what's in the cache and how well those entries in the cache are relating to reducing your I/O traffic, we can decide what are the best entries to keep in cache, which ones to throw away. And this goes, like I said, a long ways towards improving or reducing the I/O traffic that has to go to storage. So if we can offload a tremendous amount, as you mentioned, 30 to 50% or even more of the I/O traffic from going to storage, that increases your storage bandwidth and allows it to be used for other useful things, Jennifer.
Thanks a lot, Howard. Now, we're starting to run a little low on time here. We've gotten to the bottom of the hour, so please definitely start putting more of those questions into the Q&A. I see a couple good ones in here we'll get to in just a moment. So I'm not going to spend a whole lot of time on these last couple slides. I really want to get to the handoff of the software and how to evaluate the software so you can try it for yourself in your environment. I will just mention that we are a Gartner client. You can check in with them. They call us the world leader in DRAM caching technology. We can't say that we are for sure, but we believe we've sold more licenses for caching than any other player in the marketplace over the years. So let me just outline a couple of these use cases. ASL marketing right in the middle there, SQL batch import jobs dropping from 27 hours to 12 hours, And actually, I had the privilege of helping them with those installs, and I was there on the case study call, hearing the story that they had to tell, and it was just spectacular. Another one I mentioned earlier, Christus Health, with the workloads that they were trying to solve, they had a $2 million PO queued up and ready to go to do a forklift upgrade of all of their SAN environment, their back-end storage, and they threw us in first, and for a fraction of the price, they solved the issues and they canceled the PO. Hardware vendor was not that happy with us, but that being neither here nor there, these guys as well had a very similar experience. It's not on the slide, but I was involved in that deployment, and they saved a $350,000 purchase on a back-end storage upgrade with their Epicor ERP system. So a lot of really great case studies that are on our website for you, and some others, kind of story after story. Alvernia University, this was an LMS application, timeouts. Students are in the middle of taking tests and getting timeouts, and they got velocity in there. They just didn't have the budget to upgrade their hardware, didn't want to spend the money that way. They put our software in, it solved it, and students weren't getting timeouts during tests anymore, things like that. So just a lot of really positive things that we've seen the software do, especially when taken at a macro level. So let's go ahead and just get right into what the software looks like. When you get your Velocity installed, you're going to see the splash screen dashboard. It's going to show you the total IOs eliminated. It's going to show you of those how many were write, how many were read. Typically, we will see about a 30% write elimination and about a 50% read elimination. And right here in the middle of the screen, it's going to translate that to you to how much storage IO time did you save. And you can really see the compelling value of the software that way. And the really cool thing here is that the POC is very, very easy. As I mentioned, it is no reboot to install, and I do see a question in the window here that says, hey, if it's a simple installation not requiring a reboot, how do you uninstall it? How do you revert and back out? Same thing, you just uninstall it. There's no reboot required to remove the software from your system. So that's one thing. The other thing that we can do too is you can cap SQL memory, and if you don't have SQL already capped, you're probably going to want to do that to take full advantage of that DRAM. And we can talk with you, offline about your specific environment. Our cache can leverage up to 128 gigs, especially on those super, super heavy workloads where you're pushing terabytes and terabytes of data through. The smaller workloads, we might get away with 2 or 4 gigs. So we can assess your environment individually. And then also, we'll be able to then, I'd say 7 days later, log in and look at the monitor of the Velocity dashboard. Myself, Howard, one of our counterparts, can hop on the call with you for a quick 15-minute review. Now, there's a couple of approaches that we can take here, and one of them is that we can, you can install that NFR. Another approach is to do a 30-day evaluation across all of the VMs on the same host. I'm going to just say this right now. You can always get this from us later. You can go directly to our website to get it. But anybody who would like to receive the evaluation, just go ahead and drop into the Q&A comments box right now. Just drop in the phrase 30-day. And we'll go ahead and make sure that after the webinar you are sent the full evaluation software. That includes the Velocity Management Console, which is really a neat tool. That'll let you try the software across all of the VMs on a host, or even in your whole environment if you really want to. And then you can save that free NFR that we're going to give you, put that in your back pocket, and cherry pick which server you want to put it on later. So anyone who wants that, go ahead and drop that in or email us privately. The other option that you have as well is our Conducive IO Assessment tool. This is a free tool that will allow you to do kind of an IO health check. Nothing gets installed on the target servers. It's just using remote WMI calls to collect existing perfmon data off your target servers. You can see if they're even good candidates in the first place. We'll nicely color code them for you, red, yellow, green, showing you if they're candidates or not. And we can hop on a call to review that with you and talk with you a little bit more about an evaluation. So those are some of the things that we'll do for the handoff of the software. And I think at this point I've covered everything that we'd wanted to talk about in the webinar today. But Howard, I'll just tap you on the shoulder real quick if there were any closing thoughts you had before we move into the Q&A session.
No, I think you've covered it quite well, and I'm really interested. I see some great questions that have popped up in the Q&A part, so let's jump right into that.
Okay, sounds good. And let's start with, let me scroll down here and get into some of these questions. So the first question, Howard, is we're using, oh, by the way, anyone who does have to drop off, the session is recorded. It will be sent to you. We know we're past the bottom of the hour. We will stay on as long as there's questions, so, but you'll get the recording just in case you have to drop off. So we're using Azure SQL database facing an issue of insufficient memory issue or IOCP thread not available on consumer. Do you think it's the IO blender effect?
You know, it certainly could be. I mean, restrictive IO traffic is one of the biggest issues facing SQL applications and so forth. And so I would believe it would be an ideal candidate to focus and put a copy of Velocity into that environment, making sure that you do put memory limits on how much memory SQL can use, so that way it just doesn't gobble up all the memory unnecessarily. And it would leave sufficient memory for us to do a much more intelligent type of read cache to better benefit the SQL applications there.
Great. Thanks, Howard. Howard, I've already answered this one in passing, but I just want to give you a chance to add on any more about the installation. He said installation simple, not requiring a reboot. What if we decide to revert? Can it be removed? I've already said you can just simply uninstall it. Is there anything else they need to know about that?
Either uninstall or just simply stop the service. Either one would cause the product to go into a pass-through mode.
Okay, great. From Michael Chang, is the software OS-based or DB engine-based?
It is Windows operating system, or I should say more specifically Windows NTFS file system based.
Great. And Owen asks, my company is running SQL on AWS EC2 instances, not on dedicated hosts. In that case, we just really be getting the benefit from improving the Windows I/O tax since we can't control our neighbors. What percentage of improvement could we expect?
You know, I would be comfortable in saying, you know, just knowing the behavior of Windows, I would be comfortable with expecting 20 to 30% reduction in I/O traffic from a single guest VM.
Okay, great. And gosh, you know, anything to help. Since you can't control your neighbors, at least you can clean up your own house, right?
Exactly.
Are REF volumes supported? This is from Igor.
You know, not at this time. We certainly have our eye on the ball there, working diligently with Microsoft, just really kind of keeping our fingers on the pulse and seeing what the marketplace is doing, how many people out there are really making that big jump into REFS. Okay,
so Howard, here's a question that I think might blend our engines, right? It says, if the database returns a commit, which confirms that the data is on the physical media, can Velocity guarantee it will get that commit I/O to disk in the event of a crash? And I think you're going to have a really good answer on this one, Howard.
Well, you know, there are a couple of things here. One, committing data to be written to the disk is handled by Windows. And we're not actually handling the I/O back to the storage. Windows is in complete control of the I/O stream directly. So it will process and give a commit the same as it would without our software. And our caching engine is really a read-only cache at this point, and so we don't have to concern ourselves with any type of commits on writes because we're not caching any of the writes.
Great. Thank you, Howard. Michael asks, what happens with the spaces left by ignoring the smaller chunks Windows uses?
Well, those smaller spaces eventually do or will get consolidated back together, but we don't have to put such a huge emphasis on grouping all of the free space into one big giant chunk. That really is kind of pointless and a waste of system resources. If we know where the larger chunks of free space are and can pass that information to Windows, then everybody's happy with that, with the least amount of resource usage.
You know, and Howard, I think I'll add one thing onto your answer there. We did not talk about the fact that the product does have a free space consolidation engine. So that was kind of implied in your answer when you mentioned that eventually those free spaces will get cleaned up anyway. So, Michael, that is something that we definitely do address, and just kind of adding on to what Howard had answered there. Joseph has got a question here. Is there a benefit from this software for services with solid-state drives as well as disks? And Howard, if it's all right with you, I might just touch on that one real quickly.
Sure, go right ahead.
Joseph, yeah, the answer is absolutely and unequivocally yes. And this is something I alluded to but didn't talk a lot during the body of the presentation, and that is that, you know, the disk used to be the weak link, right? And that's where the spinning disks used to really be a lot slower than the OS. Well, nowadays, the solid-state drives are lightning fast. They're just wicked fast, but the OS is the weak link. You're actually not getting the full benefit. There's two things happening here. One is what we talked about the small split randomized I/O, very difficult for SSDs to process. So we want to get large sequential I/O delivered down to the SSDs, much easier for it to process. The other thing is that you also have to consider that now the OS is the weak link. You have a Ferrari and it's only going 50 miles an hour because the OS isn't delivering the data down to the SSD as fast as the SSD can handle it. So the governor, holding back that speed has moved upstream. So we want to get that governor off of the OS and have it just be able to throw out the data as fast as possible so that it can actually put the SSD to work so you can drive that Ferrari as fast as it can go. So you're still being held back. So absolutely on both counts, it would definitely help SSDs. One, you're getting rid of the small split randomized difficult to process I/O profile, replacing it with that large sequential profile. And two, the OS is now the slow guy in the race, and he's the one dragging everybody back. Speed him up so that everyone can start moving faster together. You got a weak link of the chain. Now it's the OS. So let me see here. My view kind of shifted on me here. Let me get to the next question. Here we go. I finally got to the right place. I think this is the next question. How is the cache and velocity refreshed? How does it know the data is out of date and needs refresh? And Howard, we'll tap you on this one.
So since our mini filter drivers can see all the reads and writes, we know when a write comes in that would modify data in the cache, that simultaneously at the same time that that write is being passed through to be committed to storage, it is also being updated in the cache to either invalidate that entry or upon successful writing of the data, if we deem that it needs to be repopulated in the cache, we'll do so.
Okay, fantastic. And there is another question here. Excuse me, my view keeps shifting. I'm glad everyone keep putting those questions in, but as you put in the questions in, I lose the view of the question that I had queued up. Howard, if you see the question, go ahead. I'm still scrolling for it.
Well, I think Chuck Lathrop was asking a question about SQL Server already having a buffer cache in memory for its read operations. And, you know, that is true. And we're not advocating that you would even disable that at all. We believe that there's good balance and behavior of doing that. But you can put limits on how much memory SQL will use. By default, SQL will gobble up and use as much memory as it can get its grubby little hands on. But at the same token, SQL is not all that efficient in what memory it's going to use. And we take a more holistic approach because we know that there are I/O requests that are occurring that are outside the view of SQL. Okay, let me restate that again. There are significant I/O traffic patterns that are occurring on a Windows server that are outside the scope of SQL, even though that server may be dedicated mostly for SQL operations. And it's those I/O requests that often tend to create those small, fractured, disassociated random reads that causes significant performance problems as they're passed through and intermixed with the I/Os from SQL. So we can cache the data that SQL misses. We can also cache the frequently repetitive read I/Os that are occurring naturally within Windows and eliminate a lot of that unnecessary I/O traffic such that the benefit you're getting from a SQL environment is more throughput, faster throughput, quicker response to the applications that are using SQL.
Great. Thank you, Howard. Michael Chang wants to know, does it only work on Windows Server? Yes, it only works on Windows Server. The benefit that you can get kind of on neighboring VMs is obvious in that if you've got, 100 Windows VMs and you've got 10 non-Windows VMs, you clean up the, kind of the same as the cloud question, you clean up the I.O. traffic from your 100 Windows VMs, you're just going to have an easier bandwidth and throughput for the non-Windows workloads. But yes, this is a 100% Windows solution. Next question, is this useful for SQL Server only or applicable to Azure SQL databases also? It is applicable to both. It's physical server, virtual server in your private cloud, virtual server up in public cloud. It is very applicable. We got a bunch of people who wanted the 30-day, excellent. And then Kev asks, just to confirm the software can improve the read-write, I'm guessing IOPS between a citrixhost.net application, which relies heavily on Oracle backend for read-write. Howard, I'll send that one over to you.
We can certainly, handle the intensive read-write operations and reduce I.O. traffic across the board. If it's running in a Windows environment, we're compatible, we're good to go. We can certainly improve the application performance.
Thank you. And any platform as a service available? That might start actually just being kind of a licensing question, and that's probably one we would take offline to understand what you really need there. Julian asked, does this work with SQL 2012 web editions? Howard?
Yes, it does. Simple answer there. It works with Windows 2008 R2 and above, and all the applications that you would run in those particular environments, including the latest versions of SQL and Exchange.
Okay, great. And Adrian's question was, what was the tool I mentioned? It's called the Conducive I.O. Assessment Tool. You can find it on our website to download, but Adrian, since you asked the question, I'm going to assume that you want a copy, and we'll make sure that we get one pushed out to you. So anybody who would like that free I.O. health check, just type in IOAT, I.O. Assessment Tool, so IOAT for short, into the conversation box, and we'll make sure you get that after the webinar, or you can download it from our website. Jason asks, I haven't read the question in advance, it says, on Windows Server 2012 Virtual with SQL Server 2017 Enterprise, is 25 gigabytes allocated to Windows and velocity sufficient?
In most cases, it should be, but I don't know what the usage of memory in your particular application environment would be like. We only use memory for our read caching that would otherwise be free and available. We're not going to take away memory from other applications just for the sake of caching. So there may be some memory tuning or adjustments you might need to do, but in most instances, people build out systems that have a little bit more memory than what their demands are. So I think you should be fine.
Okay, great. Thank you. And again, webinar is recorded. If you have to jump, please feel free to. We still have well over half the folks who are on the call still on. We're going to stay until the top of the hour to keep answering questions. So let me find the next question here. Howard, my screen moved on me again. Do you have the next question queued up already?
Let's see. I see that there are a bunch of some licensing questions, some questions on IOAT. Download link. I'm just kind of scanning here quickly.
We're on some of, okay, I found it. It's from Brad. Some of our servers are hosted in on-premise vSphere hosts attached to iSCSI SAN. Some of our SQL servers are in AWS. Can you speak to the potential optimization for each environment? I think on this one, I would say, mileage varies, and mileage will even vary within your on-prem environment and within AWS because it really is dependent on the workloads. You want to look at the fact that our read caching only caches reads. If you've got, for example, a SolarWinds data collector server that's a SQL database, it's 100% writes and, no reads at all happening on it, you're not going to have any read caching at all. So there's 30% of the optimization benefit on that one individual server won't be happening. So just some, you got to keep in mind that this is really workload dependent, and are your reads repetitive in nature? So in any environment, mileage will vary. Our averages that we see benefit are 30% on each VM on the write optimization and about a 50 to 60% on the read optimization. And it kind of depends on how broad and wide you want to take it. Each individual VM VM can be expected to get those average improvements. And when you compound it by installing it on all of the VMs, now you have a force multiplier effect that addresses that I/O blender effect. So the safe answer is between 20 to 30% write optimization, between 40 to 50 to 60% read optimization on any one individual VM. And then you take that into the context of deploying it to the entire environment. And as far as being iSCSI SAN attached or in AWS or on all flash or HCI or physical, the hardware component underneath is rather immaterial because we are installed directly in the Windows operating system. We are fenced by the Windows operating system, and 100% of the optimization work we do is there. Now the question is, can the disk keep up? So certainly faster SAN is helpful, but and if you've got the really fast hardware in there, can the Windows OS keep up? So we help offset either scenario. So a little bit of an indirect answer, but I hate saying it depends, but those are some of the deeper dive variables around why it depends. So I hope that did some justice to the question. Steve's question, when will you be emailing a link to download the NFR? Our marketing team will be emailing those today. So if you do not have it today, reach out to us. Check your spam filter, but immediately after the webinar, our team gets on the line. So before close of business today, you will have your NFR link. Brad, I see you have certifications from Microsoft and VMware. Any certifications from Oracle or JD Edwards? I'm not aware of any. Howard, are you?
Not really. We have certainly plenty of case studies with people using it in their environment and so forth, and I think that speaks volumes to the functionality of the product and how well it works in there to offload the I/O traffic.
And Oracle, if it's not running in Windows, we won't be applicable. But if it is running in Windows, we're good to go. And I've only come across one JD Edwards environment that I worked with, and I don't think that most of it was running in Windows in that scenario. So we weren't even able to install. So it just kind of depends how you're structured. Michael, are licenses per server, can they be moved from one server to another? Excellent question. The first question, are licenses per server? Yes, and we can also license by host. So you can license by individual server, which means, let's say you've got 5 physical servers and you've got 5 virtual servers, and in your virtual environment you have another 100 servers, and the 5 virtual ones are all you care about in those 5 physical servers, so you've got 10 total. That's a perfect scenario to license by server. Just cherry pick what you want to license. If you want to license by host, you get all you can eat. So if those 100 VMs are sitting on 7 hosts, you would just buy 7 host licenses, and 100% of your Windows VMs that are 2008 R2 or higher, and guys, we have not mentioned this on this call at all, this is an incredible solution for VDI. You can also, if you got 80 VDI clients on the host, great, they all get it, Windows 7 or above. So you can go either way, and economies of scale, the host model is better, the cherry picking, the per server is better. Can they be moved from one server to another? The licenses have a very limited transferability. So the short answer to the way this question is asked is no, they cannot. It's not a round robin licensing. They are dedicated to one VM. The comma but answer is this is kind of like a 1 or a 2-time event type thing during the life of the license. If you've retired a host, you've upgraded the hardware, or you've retired a server and you're replacing it with something else, you can have a reclaim of that license to redeploy it. But again, we're talking kind of very rare events in the life cycle of that license in a retirement or a hardware upgrade scenario. So, if you have 4 servers, you buy one license, you can't just move that around from one server to another. It is dedicated to that one instance experience. We've got a bunch of people who wanted the IOAT. Let's see if there's any additional questions before we tie off. Okay, so we've got a few minutes left here. We've got 3 questions left. If any of you are still hanging on that have any questions left at all, drop them in now. Or email us. I won't say forever hold your peace, or email us after. Does Conducive help at all with file servers that have millions of small files? NTFS usually falls apart when dealing with large file structures, and yes, we actually have very customized tools for that. Specifically, we developed them for a medical application that has this issue and also hits a size limit of a very technical thing that's in a metadata file that kind of guides all files. We've seen servers for these medical applications, also for Exchange, actually crash when some of these limits are pushed. And we do have software that we've developed specifically and exclusively to address that. The medical application we address that for is Meditech, and then we also help people with Exchange and some other applications out there as well. And these engines have been specifically customized, designed, and stress test exactly for that corner case, and we are the world leaders and the experts in that. So, Patrick, certainly we can get with you in that in more detail. Just a little bit too in-depth for today's webinar. Julian makes no difference whether the server is physical or virtual. That is correct, and it could even be up in the cloud. Kev, does your solution communicate any activity or metrics back to your systems? You would have to opt in for it to communicate anything back to us. So you could if you chose to, but it's not automatic push. You would have to actually actively select that. And we got to thank you. Very nice session. Well, you're very welcome, and we really enjoyed your participation and all of your questions. We have Brad. If licenses at the host level are licenses more transferable as hosts within a cluster? Sorry, the view keeps jumping on me. I didn't even get to finish reading the question. You're welcome, Steve. If licenses at the host level are licenses more transferable as hosts within a cluster, maybe change semi-regularly? No, they are not. If you have a kind of a high failover availability type cluster environment at the host, and some of them are kind of active passive, you would need to license both. The only exception we can have is in kind of the DR, we may be able to do a truncated licensing cost or a maintenance only for DR, but if it's an active passive environment, you would license everything in the cluster. And we got another, yes, great session and Q&A. Thank you. You're welcome. I think we'll end on that high note. Really appreciate your participation today, guys. We'll stop here at the top of the hour, and we'll get off your free software to you. And Howard, I really wanted to thank you for your expertise on today's call as well.
Sure thing, Jennifer. My pleasure as always, and good luck to everybody out there. I look forward to speaking with each and every one of you in the near future.
All right. That's a wrap. Thanks, everyone. Bye-bye.